Okay, you're back to see how to use the definite integral properties in an actual problem. So we have the graph of f of x. It's just a bunch of lines and a circle, well, a semicircle, really. And we can just use geometry. We can take the simple way out and just calculate definite integrals and area information just using geometry. So let's take a look at some of these problems. And there's going to be a few, but we can do them really quick because all we got is geometry. What I like to do is I like to look at areas, right? I like to split these up and find areas first. So this area down in the corner, starting from the far left, that'll be an area of 1/2, right? I'm just looking at area as positive, right? Don't say negative, don't say positive, don't say, hey, Purvis, but the function is below the x-axis. Well, I know, but I'm just looking at the area of the region. An area has to be positive. So let's take a look at the next part. That's a base of 1 and a height of 1, 2, 3, 4, 5, 6. This has an area of 3. This is 1, 2, 3, 4, and 1. This has an area of 5. Then we have 1, 2. This has an area of 3. 2 there. 1.5 there. Half there. Let's see, this has an area of 1/2. This has an area of 1. And then the whole circle, that has a radius of 2. So 4 pi, but that's only half of it. So the whole semicircle has an area of 2 pi. Now, with all those values, we should be able to combine and find the values of the following definite integrals. So let's get right to, oh my gosh, there's a ton. The integral from 4 to 4. The integral from 4 to 4, easy, 0. The integral from 0 to 1. Integral from 0 to 1, that's just that little spot here. Here's the integral from 0 to 1. That's just going to be 2. Easy, got it. All right, so integral from 0 to 1 is 2. Integral from 1 to 3. Integral from 1 to 3, that is the rest of that area. Right here. So here's 1 to 3. Grand total, that is also 2. So that part is 2. Now, jump to the next line. Integral from 0 to 3. Integral from 0 to 3. Well, hey, I already know 0 to 1, and I know 1 to 3. So the integral from 0 to 3 has to be the sum of those two things. So that's just going to be 4. What about the integral from 3 to 6? You see how all these integrals are moving to the right? So the integral from 3 to 6 of this function f, well, that's below the x-axis on that interval. So it'll be negative 1.5. Oh, and then flip it around. If you flip the limits, 6 to 3, well, you flip the limits, you flip the sign. So that's going to be positive 1.5. Keep going now. Okay, 0 to 6. I don't need to look at the function anymore because I know 0 to 3 is 4, and I know 3 to 6 is negative 1.5. I can combine those two together and say that's the same as 0 to 3 plus 3 to 6, and that's just going to be 2.5. 6 to 10. Well, I've already put in the work. I know that part was the circle. That part is just going to be 2 pi. 10 to 6, come on now. Flip the limits, flip the sign, negative 2 pi. All right, 0 to 10. Look at this. Boom. Covering up the graph. We don't even need it. Because 0 to 10, we can add a couple of the pieces that we already know. How about the integral from 0 to 6 plus the integral from 0 to 10, using that property where you can use that same value, pick up where you left off. We're going to add those two values together. How about 2.5 plus 2 pi there? All right, 10 to 0. Flip the limits, flip the sign. It's going to be the negative of the one we just did. So negative quantity 2.5 plus 2 pi. All right, new little region, negative 1, 2, 0. All All right, -1 to 0 is still moving to the right, and the function is above, and that was what we marked as 3 earlier. So that has an area of 3. -3 to 0. -3 to 0 is all 3 of those little, so 3 and 5 and 3, 11. All right, that was 11. Oh, come on now. 0 to -3. I know what you're trying to do. Trying to make me think too hard. No, it's just flip the limits, flip the sign. That's -11. How about -4 to -3? It's moving right, but this time the function is below. So everybody that was screaming at me earlier in the video to make that little critter -1/2, well, now is your opportunity. -4 to -3, right? Function below. The value of the definite integral is -1/2, even though the area is +1/2. All right, so -4 all the way to 0. Don't need the graph anymore because I know that's just going to be the sum from the sum of two integrals I already know. How about -4 to -3 plus the integral from -3 to 0. So I'm just going to add those two together. So let's see what those values were. -1/2 plus 11. That's just 10 and up. Half. For a second there, I couldn't add. Okay, -4 all the way to 10. Again, don't need the picture. I'm just going to add some things that I already know. -4 to 0 plus 0 to 10. How about that one? -4 to 0 we just did. That's 10.5. 0 to 10, that was 2.5 plus 2 pi. If you add those two together, you get 13 plus 2 pi. All right, 18. Ooh, what is this nonsense? Absolute value. Okay, what are we absolute valuing? That's right, we're absolute valuing the value of the definite integral. So we're going to do the definite integral, then do the absolute value. Well, we already have done that one before. 0 to 10 was 2.5 plus 2 pi, and that's already positive. So that's 2.5 plus 2 pi. Ooh, what about 19? What are we absolute valuing? We got to absolute the function first. We absolute the function first. And let's think about what that does. Function transformationally, that flips all the function bits above the x-axis, makes all the output values positive. So all those pieces of the function that were negative, that were below the x-axis before, are now above the x-axis. I'm talking about you, little triangle with an area of 1/2 below the x-axis right there. Looking at you, buddy. So the integral from 0 to 10 of the flipped up version, the all positive version, would be 4 there, 1.5 there, 2 pi there. How about 5.5 plus 2 pi? All right, 20 is absolute valuing the entirety of the value of -4 to 10, which if you look right above it, we calculated that to be 13 plus 2 pi. Already positive, so that's just 13 plus 2 pi. And 21 is a lot of stuff going on. First of all, we've got a constant that could be factored out. So how about 2 times? We've also got a limit situation that looks backwards. So if we flip those limits, we can say that it's negative integral from -4 to 10 of the absolute value of f of t dt. And now, remember, absolute valuing f means the function changes. All those little pieces are above the x-axis. So -2 times, let's go back up. So this little critter here, that's now +1/2, +11, +4, +1.5, and +2 pi. So all that grand total is 2 and 4, 6 and 11, 17 plus 2 pi. and then multiply that by negative 2. I'm not going to worry about that. That's negative 34 minus 4 pi. No big sweat. All right. Come back for the last video. It's going to be short.